try on our side to present a summary of the Grenoble transnational accesses actions. It is a summary about the activities within the Mexico.fr platform. Mexico in French means moyens expérimentaux pour la conception, experimental resources for design activities. And we are mainly supporting this work with a local team, which is built with Cédric Masclé, also Rémi Larcher, Thibault Louis and Patrick Maigreau are there, all of us, here for this presentation, and who participated to the transnational access I will show you. For the moment, we have one application which has been fully completed. We have two more which are planned for March and that will be executed very soon. I will discuss about the content of these TNAs which are formally ready now. We have 3 more applications which are accepted and under preparation, and we expect a new one which is under investigation for application. Obviously, we are still expecting one more to fill the TNA goal with these figures, and we will try to solve that as soon as possible, as we must all do that. We also participated to other TNA projects, indeed, by participating to the ICT demonstrations with the dancers in Vilnius while it was physically in Grenoble, but the virtual dancer in Vilnius, and the musicians in I2CAT, PSNC playing together. So this demonstration was also with our support. We are also organizing a project from Grenoble Lab, which will go in RWTH, but was needed some local support before going to the transnational access model. So we are doing that. We are organizing also another project with an observatory of space activities. I will show a slide about that. And it is still under discussion to see what we can do on this element. And we participated to various promotions of projects towards other partners during the last 2 years. What is Mexico? Just a few slides, a reminder about what we are providing. We are providing 2 interconnected rooms, one which is more a collaboration observatory lab with a multi-touch table and devices to capture and build collaboration corpus on audio and video mode, and also tools and processes to analyze micro activities during collaborative design. This is a main goal of our applications here in Grenoble. We have also a second lab to deploy augmented reality and virtual environments, which is connected to the first one, with 3D stereoscopy with optical tracking system, holography, head-mounted device, and upcoming upper wall, which is under installation right now. And very soon we will have also a mini desktop cave, which will be organized in the next months. We are supporting all these activities and the connections of all these devices through software development to support interoperability between all our facilities, which is named Collaborative Virtual Environment, which help to have an easy configuration of behavior of a network of devices with virtual sense handled in these topics, and which is based on a model-driven engineering approach as within the kernel model. So this is our main resources. With these resources and these tools, you have an overview of these elements. On the bottom left, the design observatory. Just on the top of this design observatory, one collaboration activity which is tracked during collaboration in order to analyze the microactivity of these elements. We have also capacity to create assembly, disassembly process with haptic devices, what you see on the top of these 2 first pictures, the multi-touch surface, one HMD and tracking system with OptiTrack facilities. We are applying that for surgery simulations and experts observation, and we have also an holographic screen which help us to have not immersion but augmented reality indeed, since the scene can be mixed with the 3D physical world. With that, we mainly provide collaborative design within multimodal environments. That's one of our main objectives, and we claim also to build an intuitive design office where we would like to create an efficient environment for every design activity. So that's the main topic of research we are developing in our team with this kind of equipment.
So this is our first TNA. The host is Ettore Lanzarone, a PhD student from Milano. And the subject is data visualization for the complexity of human resource planning in home healthcare. Okay, so Ettore Lanzarone deals with healthcare planning and optimal allocation of nurses to patients. So his research question is, may visualization and interaction technology help to support complexity management when optimization techniques are not satisfactory? In fact, an important question is how to switch from automatic analysis to human decision. So he has some patients and some nurses, and the purpose is to be sure that nurses visit the patients who need health care. But the problem is to get optimization technique in order to make these choices. So they have an algorithm who can make this optimization, but he cannot. They are running it only on weekend because it's very long to run. One important thing is to take care with several constraints and to be able in real time to deal with real-time difficulties. The constraints are that care must be provided in due time, of course, and sometimes there are patients who need certain nurses only. Then we must be sure that the nurse has a good schedule. One optimization can be also to be sure that a nurse has not too long time between two different visits. So it can be reduced to a commercial traveler scheduling issue with many travelers. For now, the solution that they have in order to schedule the visits is a software, not very beautiful, and with many weaknesses. The weaknesses are that they are not, principally they are not allowed, they cannot work together in a collaborative way because they are all the scheduler. One of the main problems here is that there are several people who are working on the schedule of the nurses' visits. So they have to, and each scheduler is take care of several nurses. So it's not very easy for one scheduler to know when one of the visits that he should be able to do as difficulty, how to communicate it with the other scheduler in order to have another nurse, for example, to cover it. Those are the problem of agents and traffic delay in the real time we are talking about. For now, there are four schedulers with their own software, and they try to have oral communication to take to be able to reschedule in real time. So a 10-app process, so it's obvious for you, I guess. So the new interface that we have introduced here is a diamond touch devices that Frederic presented before. It's a horizontal tactic surface, as you can see on the screen, which allows to detect several multi-touch and to detect which person touched the screen at which place. So it's a very powerful device for a collaborative environment, and which with a very large screen, which allowed to improve tangibility of information. So we had to change the metaphor in order to be used in this with this special device. So we have 4 planners individual areas. If they are not, if they are in front of, for example, the top one seems to be upside down, but it's because everyone is around the table. So each panel is in the right side for every scheduler. They have a common map in the middle. I don't know if you can see, but there are little blue points which represent the patient. Those points never move. And some red points which represent the nurses. And those points move on the map in real time. This is very pertinent for the tangibility of the information, because each one of the user have his personal area, so he can have the information he wants without disturbing the other. You can touch directly on the map in order to have information. And if you want some information about nurses, you just have to select it, and you have the information on your personal panel without disturbing the others. And you have some high-level interaction between the schedulers. You are able to, if I come back, you can see that there are some buttons here, for example, beside all nurses, which allows you to delete a schedule or to let another scheduler to integrate it on his schedule. So it's a powerful collaborative interface. We made some experimentation in order to know how it works. So a real situation recorded in past weeks. So of course the individual names are fake, and we tried both with a single planner and with 4 planners to manage events. So in a situation that the real scheduler had to deal with in the everyday life. As we can see, this powerful device with the tangibility of the information made 4 collaborators too many to schedule and to reschedule in real time. Only one is enough for this kind of data.
So the metaphor simplified greatly the perception of the information and hence reduced the complexity of the issue. That was the main conclusion, I guess.
Yeah. So in order to be sure that the collaborative is useful here, because it is what we wanted to demonstrate, we try to simulate a pandemic, so with a large number of patients and few nurses. So first thing we see is that we need to have some zoom in and zoom out in order to navigate on the map that we didn't develop yet. And what we could see is that there are difficulties. So even for several planners, it's very hard to handle this kind of pandemic. But it's much more realizable than without this device. So the scientific outputs. So we have two things. We have the optimization algorithm and we have the human cognition. So human decision in real time. What is best for what? The optimization algorithm is best to because if you have time, of course, to run the optimization algorithm, and if you know every specific data, you can have a very efficient problem solving. But human cognition is preferred when, for example, you have subjective choices that could be better than every optimization. And when you need to reschedule in real time, the map give a real help to have the best optimization without an algorithm. For example, if you want to reschedule one visit very quickly, you can see on the map the nurse who is closer, and click it on it. You can see if you can let her know that a new patient has to be visited. So it's very fast and very user friendly for the planner, and you don't need to have an algorithm running to take this kind of decision.
That was not finished indeed. If I just go back to the last system, we had two communications about this TNA, one in Cogem 2013 and one in GVRC 2013 also, presenting this kind of scientific outputs. But it is not finished anyhow. What we defined previously was clearly that it was, with a new metaphor, it was possible to solve some complexity issue or some apparent complexity issues. Ettore Lanzarone told us that it could be better to get now an evaluation of this complexity and the limits of this evaluation, and it is what we will propose to do in the next transnational access with Ettore, who will come back in March in order to make this evaluation. I would like to say also that it was a quite long organization for the first thing, because we developed fully the application for this transnational access, while we were not able at the beginning to offer this kind of service and this kind of applications. So what we would like to do in the next TNA is to get a better knowledge about the adequacy of the support environment with respect to the context. We could compare the above results with other types of metaphors and interaction solutions. By example, by complexifying the avatars, and why not the maps, which could undertake much more details within the map, the roads, the lakes, the things like that, which can be important for the decision to move someone to one location to another one. The direct path is not always a straight line between 2 points. The previous models associated to a generic knowledge of correlations between context and adapted support will be a real direction of research in order to find what kind of equipment, what kind of environment will create a very intuitive and easy situations for the collaboration. And we try to make this map. We will try to have this knowledge with this TNA 138. This is a quite important point, I guess, that we will try to create new knowledge in order to better understand the connections between the environment and the specific context. At last but not least, we should refine the current experiment to define the maximal complexity that can be handled by a single planner with a dedicated metaphor. And that's one point also that we will try to solve in the next series of experiments with Ettore Lanzarone. We are working also directly on other transnational access projects. One which is really ready now will be with Robert Jacob from Romania, who will try to work about assembling a simulation using haptic device. Indeed, the research question in this project will be to compare the effect of force feedback within assembly application by using either an haptic arm, which has 6 force feedback degree of freedom, with a space about 50 centimeters in order to move the hands and to navigate in the sand. This action arm will be compared to a more simple and cheaper phantom arm with a space about 20 centimeters of movements and only 3 force feedback degree of freedom over since the rotations are not have not feedbacks, and we would like to see if it makes a difference in assembly, in assembling the parts, and so on. So we also, in this case, built a complete application to assemble parts, where we can manage collision handling with kinematics joints driven by the application when the parts enter in coincidence and in the positions of the joints, with possible available analysis criteria of this activity, which are the docking, the duration of a task, and the stability of gesture. To be more comprehensive, since it already works now, I can show you a video about the system, where you will see just the application, which works on a stereoscopic viewer, with Thibaut handling all the sand here directly with the haptic arm. It can take a part. We can play with collision with all the other parts and move towards the assembly of specific joints, where when we have the kinematic joint which is detected, we have a complete driven kinematics with the haptic arm. So here you can put another part on the system, and like this it can assemble all the parts just by selecting the parts and connecting them to the right locations in the system. So these models will be evaluated for a series of experiments in March in order to compare 2 different haptic arms, one cheap one and a more expensive one, which is ours. I come back on the presentation just to follow with the next project we have in mind for the moment, and we are trying to prepare for before the end of the year. First, we will have a project with Subserge Camille about the virtual Roman city. The research question which is asked by Subserge Camille is to investigate interest of virtual reality and augmented reality for very pragmatic archaeology. That means that he wants to measure some archaeological sense and to go and to get a process in order to collaborate with other archaeologists archaeologues in order to make decisions about where to dig, where to advance on the archaeological process. In this case, we experiment and we plan to use photogrammetry to recreate very quickly some graphic sense by complementing them with 3D modeling from Blender or other 3D modelers, and we will try to combine that in order to provide a full process from the measures on the direct site and physical site towards virtual reality in order to enable collaboration between archaeologists in this sense. We will have then also a second TNA project, which is not yet planned, but we are preparing the work with Jubi Tieni Grazina, who is from Hungary, I guess, if I'm not fake in this, with the idea to visualize non-convex multi-objective optimization data in order to support and to help the optimization algorithm to converge. In this case, the point is to immerse the person in a 3D scene where we can see the answer surface of the optimization tool and try to support the focus on several areas of optimization. We have also the project of Vytautas Bicinskas from Vilnius in Lithuania, who want to support the analysis of robot path generation and visualization with an application for virtual industrial robot learning. That means that indeed we can simulate and anticipate the path generations of a robot, but when you come in a manufacturing plant, usually the robot does not do exactly what it's supposed to do. There are some troubles that can appear because of unpredicted collisions and things like that. In this case, we will try to provide support to the correction of the robot program within virtual reality if we can better assess the various collisions that we can do. Here, the main issue is to get a G-code visualization of the various connections and joints of the robot in order to reproduce what has been simulated by the mechanical engines. We have also another project. We are not confident about his application right now. From Liverpool. He was in University of Salford. He moved to Liverpool to depict the impact of augmented reality technologies in collaborative architectural design, but for education applications. Unfortunately, with the move from University of Salford to Liverpool, this project is somehow in danger now. So we try to reactivate it very quickly, but it's always a complex thing to ensure. At last but not least, we will have an expected application which is in discussion now with Spanish partners in order to assist to the end speech and to support learning of the end speech within virtual reality and augmented reality system. So this is an overall view of all the TNAs which are playing for the Mexico.fr facility right now. We have been also involved in other TNAs, I said it just at the beginning, with ICT performance demonstration with a dancer immersed in a virtual scene with remote musicians. We are working right now with RWTH in order to analyze this sand sample, which is from a laboratory of soil, solid and structures, which aims to analyze and to create a behavior law of a sand material. And here the point is, we have now the data, and the point is to analyze all the grains which are moving together in order to better detect the real behavior law of this sample of sand. That's a very interesting point for scientific visualization, and it is interesting for us because it's a connection for scientific visualization. We will have also some applications in scientific visualization with what we can do with a space observatory, where we are preparing the analysis of the results of the sonde Rosetta. Maybe you listened about this Rosetta platform, which has been sent 3 years ago, which will be at close to the location of the comet Churyumov-Gerasimenko in a few months, and where they will have a lot of information coming from a sensor which will be sent to the comet itself. We must help to the decision of the satellite positions and of the sensor position on the comet. That's a first problem where there is a 3D analysis of the electromagnetic fields, which is quite complex and that could be eased in an interactive way. And we will support also, after that, the analysis of the results which have been scanned by the sensors, but it will be done offline, not in direct decisions, so we will have more time in order to analyze this kind of elements. So we are working for that. We hope to host a transnational access project from this project by inviting someone not from Grenoble, but from a contact of the observatory in Grenoble, and we hope also that we will be able to send someone from Grenoble for another TNA in another location within Visionair on another partner of Visionair facilities.
Yes, I have a question, some curiosity about how did you model the cinematic joints in the assembly that you showed us with haptic? So you have an ontology for that, it's just modeled using a CAD system. How do you model the different kind of joints?
So currently, for the example I've shown on the video, clearly it has been created from scratch. That means that we identify ourselves all the kinematics and the joints. But we are participating also with in RIAREN to joint research actions, which is the 9.1 research actions, where we have Gilles Foucault in Grenoble INP, who is developing a system, an automatic system, in order to find the kinematic joints automatically from a step file, not from a CAD file, from a step file, where kinematics joints are not included usually. That means that we fix position of parts in a specific position. We should be able to recognize the joints of the kinematic system. With this system will be produced as a direct algorithm, taking a state file and returning an XML file with all the definition of the connections and the potential connections. We will provide it as a web service in the next weeks. It's not operational right now, but we will be able to provide a web service where you will be able to upload your state file on our server, and we will send you back directly the kinematics joints under an XML formatted file to be used for any virtual reality scene organization indeed. And we imagine to use that in order to operate more systems than what we can use right now. Obviously, it will be possible also to take the CAD system when the CAD system has direct definition of a joint, of kinematic joints. We could make a macro definition in order to get this output directly towards our system. With Robert Jacob on this TNA project, we should do, Robert Jacob promised us to provide a macro from SolidWorks in order to extract this kind of information from SolidWorks.
The export from CAD, the automatic export from CAD, as Robert Jacob, if I remember well, it's Robert. Huh?
Yes, Robert.
Robert will do is interesting. If we could test that macro in SolidWorks to see what it produced, it will be very interesting, obviously.
We did it already 5 years ago in order to export 3D model from SolidWorks and to get the kinematic connection. So I know that we can do that. It was not done very properly by the PhD student who developed that in JSCOP 4 or 5 years ago. So I know that what is supposed to be done by Robert Jacob can be done quite easily. Just enter in the CAD model and make some queries in order to get the joints and to position the joints with respect to every part. It is interesting, but indeed it is not enough, because when you have that, you can have only the joint connections which are agreed by the system for a specific organization of the system. You cannot take a screw and move this screw to another location with a hole which is compatible with this screw, because the screw is dedicated to a single hole. So what we try to do with Gilles is clearly to identify this kind of connections, but independently of the position of the part, in order to be able to put any screw which has a diameter 10 with any hole which has a diameter 10. That's the main purpose, which cannot be done with a traditional CAD system. So I guess this kind of solution will be much more interesting in the future, but this is also a starting point with a joint research action to get